Today we are going to talk about FCP. We will start FCP. So in SAN, as we discussed, we have two protocols, right? One is iSCSI, another one is FCP. We have already discussed about iSCSI, how iSCSI will work, like what are the things, what are the steps we need to follow in order to configure iSCSI. We have discussed about all of them. Now let's talk about FCP. FCP means fiber channel protocol. Okay, that is the full form of FCP. Uh, Unlike NAS protocols and iSCSI, FCP will not use LAN network. Okay, we need a dedicated network to configure fiber channel protocol. Okay, like so. Yeah. So when it comes to fiber channel network, okay, we have different topologies to configure the fiber channel network. Topology means nothing but structure, architecture of the network. How we can build the network. The architecture of building a network, we'll call it as a topology. It is a kind of a design diagram, you can say that. Okay. So there are three topologies in fiber channel SAN. One is point to point. Second one is FCAL, fiber channel arbitrated loop. Third one is switched fabric. So we'll talk about each and everything today. Okay. First, let's discuss about point to point. So point to point connectivity. A point-to-point connectivity is a simplest fiber channel configuration. Two devices are directly connected to each other as shown in the figure. That means in point-to-point connection, for example, if you want to configure a point-to-point fiber channel topology, then only two devices will be there. Okay, and these two devices will be connected to each other directly. Simply, let's assume this is my server. Okay, and this is my storage. Storage. So these two devices will be connected to each other directly. Like there will be nothing, no SAN switches, nothing, no medium. Okay, they'll be connected directly via fiber channel cable. Okay, fiber channel cable, FC cable. That is what we'll call it as point-to-point connection. So in point-to-point connection, only two devices will be connected to each other. That means my server HPA will be connected to storage FCA, storage fiber channel adapter directly with a direct connection of cable. That's it. This is a point-to-point. So why we'll call it as point-to-point? Because this is one point, which is my server, where my server is. This is my another point where my storage is. So only two devices can be connected in point-to-point network. Okay. So this configuration provides a dedicated connection for data transmission between the nodes, right? We'll be having a cable connection dedicated. This cable connection is dedicated for these two devices only, right? No other device are sharing that connection. That is the reason we're calling it as a dedicated connection between the nodes. Nodes mean nothing but our server and storage. This configuration provides a limited connectivity, obviously limited connectivity, right? Okay, we can connect only two devices. If you want to add more devices to this network, then point to point, you need to change the topology. You cannot use point to point for if you want to connect more than two devices. Okay. So as only two devices can communicate with each other at a given time, and it cannot be scaled to accommodate large number of networks. So what they are saying is only at a time, only two devices can be uh, communicate in the point-to-point network, because only two devices will be there, right? And we cannot scale the network. That means we cannot add more devices and increase the network. It is not possible in point-to-point topology. Okay, that is what they are saying. Point-to-point, there's nothing complex. It is pretty simple. Direct cable connection between the server and storage. That's it. No other configurations required. Next thing, FCAL, fiber channel arbitrated loop. So this fiber channel arbitrated loop is a another topology where all the devices will be connected to each other in a ring manner. Okay, for example, let's assume that these are the devices and this is my server. Okay, this is my storage. This is another server. Like that, all the devices will be connected to each other. Okay, let's assume this is a switch, and again this is a server. Okay, all the devices in point FCAL topology will be connected to each other in a ring manner. Okay, so for example, if this particular server wants to communicate this server, it cannot go in this direction. Okay, it cannot go in that direction. What it needs to do, it has to travel all the way and it has to communicate like this to this particular server. Okay, this is how. So FCAL topology is similar to a ring topology in network. In normally in network also we'll be having a lot of topologies like ring topology, mesh topology. A lot of topologies are there in normal network. I don't know people from BTech background. They'll get all these concepts in computer networks subject, I guess. Yeah, I don't remember. Okay, but yeah, computer networks, you'll get all these concepts. So okay, similar to a ring topology in network. That is what they are saying here as well. So all devices will be connected serially in a loop or a ring similar to the token ring in the network. So in this FCL topology, all the devices will be connected in a loop, serial loop. Okay, every device has a transmitter and receiver. I told you, right? So if you if it is a SAN, then you'll be having HBS. In HBA, we'll be having transmitter and receiver, right? So with the help of transmitter and receiver only, they'll transmit the data, receive the data. Okay. But even though we have many devices, only two devices can communicate with each other. Okay. Only two devices can communicate at a time. Rest are blocked. This is called blocking technology. That means, for example, now this server is trying to communicate with this particular storage. Then when these two are communicating with each other, remaining whatever the devices, they cannot perform any transactions. They cannot communicate with each other. They have to, the communication between them will be blocked. Okay. Even though if you have 100 devices in a ring, only two devices can perform IO operations at a time. Okay, remaining things will be in blocked state. This is the reason we'll call this as FCAL as blocking technology. Okay, the failure of one device can cause a break in the ring. That means, for example, here in this scenario, I have 5 devices. If one device got failed, for example, let's assume that the server got failed. So when my this particular device, okay, for example, this particular device has to communicate with this particular device, then it has to travel like this, right? But as there is a break in the ring, it will be not able to make the communication like that. Even if one device got failed in the ring, entire network will goes down. Okay, that is the reason most of the organizations, not most of the organizations, 99.99% of organizations, they are not using FCAL. Okay. Even a single device or even a single connection failure also will impact the entire FCAL network. The FCAL follows 8-bit pattern of addressing called ALPA. Okay, that means nothing but normally how we can identify each other with our names, right? Okay, the same way, and in normal network, how one device can identify other device with the help of IP address or with the help of MAC address, right? The same way, here also, whenever you connect a device into a fiber channel arbitrated loop network, then the device will get an address. Okay, the device will get an address. That address is the size of the address is 8 bit. Okay, 8 bits is the size of the address. So with the help of that address only, the other devices in a loop will be able to identify that device, and they'll be able to communicate with each other with the help of that particular address only. And that particular address, we'll call it as ALPA, means arbitrated loop port address. Okay, every device will be having 8-bit addressing, 8-bit pattern of addressing. Okay. Only 127 devices are supported, as the rest are affected by positive and negative volts. That means in a single fiber channel arbitrated loop, it is recommended to connect only up to 127 devices. If you connect more than that in a single loop, there might be performance impact, or you might notice the connectivity issues. Okay, that is the reason the maximum number of devices, the FC standards designed. Okay, they it is the best practice is to connect only up to 127 devices, not more than that. If you connect more than that, yeah, there are you need to face some issues like connectivity issues or performance issues like that. Okay, so let's talk about the limitations of FCAL. Again, same thing, same points they'll repeat. FCAL shared bandwidth in a loop. Only one device can perform IO operations at a time. So whatever the bandwidth we have, everything will be shared across the devices, right? That is the one thing. And only one device can perform IO operations at a time, right? See, now these two devices are communicating with each other. Okay, that means one device is copying data to another device. That means only one device is performing IO operations, right? That is what they are saying here. Next, each device in a loop has to wait for its turn to process the IO request. The speed of the data transmission is low in FCIL topology. So when these two are communicating and this particular device is writing data to this, remaining all, they have to wait for its turn, right? Once this request got, I mean, the transactions by this server completed, then the other device will get its turn. Until then, it has to wait, right? It will be not able to process the data, will be not able to write or read anything, right? So the performance in FCILE is very low because of its mechanism. Okay. FCAL uses 8-bit pattern of addressing, blah blah blah. This is already we discussed. We can connect only 127 devices, and every device will be assigned with a 8-bit addressing pattern. Okay. And one more thing is adding or removing devices results a loop a reinitialization, which can cause momentary pass in loop traffic. That means if you want to add a new server or storage, or if you are removing existing server or storage to FCI loop, you need a downtime. You require a downtime. Whenever you are adding or removing that particular device, uh, yeah, the entire loop will goes down for a few seconds or few minutes based on how quickly you are doing it. Okay, but basically you require a downtime. This is not a non-disruptive, this is a disruptive procedure, adding or removing something to the loop. Okay, any questions?
Yeah. No, no, I'm good.
Cool. Now second, I'm looking for one diagram. Just okay. Not this. That's okay, I'll try it. Next topology is switched fabric topology, which is a most used topology. This is the topology which everyone will use mostly. Most of the organizations will use switched fabric topology only. Okay. So here we'll create a SAN network with the switches first, and we'll connect servers, storages, everything to that SAN network. Okay. Let me show you first. See, what I'll do generally, I have 4 switches. Okay, let's assume that I bought a 4 SAN switches and I connected first 2 SAN switches together, and I connected second 2 SAN switches together. So what it will do, it will create a, it will create 2 SAN networks. This is SAN network 1, SAN network 2. Generally, SAN network, technically we'll call it as fabric. Okay, technically we'll call SAN network as fabric. Okay, let's assume that this is fabric A and this is my fabric B. Okay, 2 SAN networks. Now what I'm going to do, I'm going to connect, let's assume that I have 2 storages. I'm going to connect my 2 storages to both the SAN networks. In the same way, I'm going to connect my second storage also to both the SAN networks. One of the switches, like one of the switch ports, will do the connections. Okay. The same way, let's assume that I have okay like this. That means now all my servers will be able to communicate with my storage via both fabrics. Why we created 2 SAN networks? Why can't we keep all 4 switches in a single network? Because due to some configuration issue, if one fabric went down, still my servers and storage will be able to communicate with each other via the second fabric, via second SAN network. That is the reason we'll configure most of the organization, not most of the organizations. It is a standard you need to follow. Even if you have only 2 switches, you need to configure one SAN network with one switch, another SAN network with another switch, like that. Okay. uh, you must create a 2 fabric network. That is a best practice actually you need to follow. Okay. So yeah, so that is the reason we'll configure 2 SAN networks. We connect everything, all the servers and storages to SAN network. So here see, I can connect multiple servers, right? And I can connect multiple storages to SAN networks. So I can present storage from this server. I can present storage from this server to all the servers, right? Like for example, I ran out of space on all these servers. What I can do, I can buy one more storage, and I can connect the storage to my SAN network, and I can start presenting storage from that particular device as well, like that. So switched fabric is a best network where you can connect very you know like there is a limitation, but the number is very big. Like you can connect like 16 million devices to a single fabric network. 16 million. Okay, nobody will use that much. Okay, like that. So that is the reason most of the people will prefer switched fabric topology only over point to point and FCIL. And here you can remove the device anytime, you can add the device anytime, you don't require any downtime. Nothing, nothing, no existing environment will be impacted because of adding or removing a device. Okay. So this is a well-designed network. Okay. So yeah, let's talk about that. So that is what they are saying here as well. Fabric is a well-designed, intelligent, and self-configurable network that follows FC standards. See, when you compare it with point-to-point or FCAL, switched fabric is a topology which will follow the FC standards, and it has advantages as well. Like it is a well-designed. Because of that particular design, we don't have any single point of failure. That means even one SAN network fails, I have another SAN network. If one HBA fails, I have another HBA, like that. If one FCA fails, I have another FCA, like that. Okay. And intelligent and self-configurable because I'll tell you. Okay. It is called self-configurable because the ports of the fiber fabric are intelligent and software specific. They configure themselves according to the devices connected to them. That means, for example, I have connected server to one of the switch port, then that port will communicate, configure it on its own according to server configuration. Like that means the speed, the port type, everything will be automatically configured by switch port itself. The same way, if I connect storage to the switch port, it will configure itself according to the storage configurations. For example, I have connected another switch to this switch, then the port will automatically configure itself according to other switch configurations, like that. So that is the reason we are calling it as self configurable and intelligent. Okay. In a single fabric, we can connect 1 to 239 switches. Okay. We can connect. That means uh, earlier I draw a diagram, right? In that I've used only two switches in each fabric. In fabric A, two switches. In fabric B, two switches. But you can go up to 239 switches in a single fabric. That means 239 switches in a fabric A and 239 switches in fabric B, like that. Okay. That means, for example, for time being, initially I created a fabric with only two switches, and I don't have free ports now on these switches. What I can do, I can purchase one more switch and I can connect that switch to existing network so that I'll get free ports. When I'm running out of ports on third switch as well, I'm going to buy another switch. Like that, you can add up to 239 switches in single fabric. Okay. Uh, they're practically saying that 239 switches, but the maximum, the biggest fabric I saw in my entire career is 12 switches fabric. Yeah, 12, I guess. Yeah. That is the biggest fabric I saw in my entire career. Uh, Even to that fabric, we connected like uh, hundreds and thousands of servers storages. Okay. Yeah. Again, the number of devices we can connect and all depends on, not only depends on number of switches, depends on switch model as well. We'll be having a lot of switch models. Few switch models will be having thousands of ports. Few switch models will be having less number of ports. Again, that is also depends on the switch model. Okay. Yeah. In a single fabric, that is what you can add up to 239 switches, and 1 to 239 domains, as each switch has its own domain ID. Okay. Now, in SAN network, in switched fabric network, we'll be having multiple switches, right? Then how come one switch will be able to identify another switch? That is based on the domain ID. Every switch will be having a will be assigned with ID. Once we add the switch to the fabric network, it will get an ID. Okay. With the help of ID only, one switch will be able to identify another switch. So that particular ID, will call it as domain ID. Okay. That particular ID, we'll call it as a domain ID. When we add the, when we created a fabric with switch one, the first switch will be assigned with a domain ID one. When we add another switch, it will be assigned with a domain ID two. When we add another switch, it will be assigned with domain ID three, like that. Okay. Every switch will, when we add a switch, it will get a domain ID. Next, switched fabric addressing. So 1 to 239 switches can be placed in a fabric. Again, same thing. Every switch is identified by a domain number and up to 239 domains are available. That's okay. Again, same thing. The addressing pattern followed by a switch, uh, followed in a switches is 24-bit addressing called PID. Okay, that means in a FCAL topology, when you connect a device, 8-bit pattern of addressing will be assigned, right, to the device, and with the help of that 8-bit pattern of addressing only, one device will be able to identify another device, right? The same way in a switched fabric, okay, in switched fabric, every device will be assigned with a 24-bit pattern of addressing. Okay, that address will call it as port identifier address. Okay, with the help of this 24-bit addressing only, my server will be able to identify storage, storage will be able to identify server, like that, or one server will be able to identify another server, like that. Okay, so practically up to 16 million devices can be connected to a fabric. For example, you have created a fabric with 239 switches and you have used high-end switches, then the possible number of devices we can connect to a single fabric is 16 million. That is a theoretical number. But practically, when this document got created, it is only maximum of 16,000 devices. That is a practical thing happened during that time. Yeah, 16,000 devices, servers or whatever it is, storages, it is not a small number. Okay, yeah. Any questions on switched fabric?
No, Annaya.
Cool. So let's talk about a few more things. Let's talk about fiber channel layers. I don't know that how many of you are remember. In normal network also, we'll be having layers, right? We'll call them as OSI layers. Okay, we'll call them as OSI layers. Same way, in fiber channel network also, we'll be having layers. In FC fiber channel, we have 5 layers: FC0, FC1, FC2, FC3, FC4. FC0 is a physical layer. Okay, FC1 is a encoding and decoding layer. FC2 is framing and flow control. FC3 common services. FC4 upper layer protocol. Like, this is a very in-depth concepts. Like, if you want to understand each and every layer in detail, okay, uh, you can go through it, but I'm not going to cover all layers in detail as part of this course, because brocade itself, it is a, I mean, SAN itself, it is a very big course. Okay. Mm, but even when it comes to interview also, nobody will ask you in detail about the layers. Maybe they'll ask you how many layers are there in fiber channel. So you need to name all these layers, like physical layer, encoding and decoding, framing and flow control, common services, upper layer protocol, like that. Okay, like that. Okay, so you need to remember that. And if you are interested, just go through this document. This document explain not in detail, but I'll share this document with you. This explained little bit in depth only. What each layer will do, what will happen in each layer. Okay. Next, we'll talk about frame structure. Okay, frame structure. So, what is frame actually? Normally, I told you, right? In normal network, whenever you are copying some data over normal LAN network or IP network, it will be divided into small packets, right? And it will travel over the network and it will copy to the destination. The same way, whenever you are copying some data via SAN network, the data will be divided into, the data will be traveled in the form of frame. Okay? The data will be traveled in the form of frame. So each frame size will be 2148 bytes. Like, for example, if you are copying some 10 GB of a single file, then it will be divided into small frames with a size of 2148 bytes. Okay, so every frame, the architecture is same, every frame structure is same. Okay, uh, yeah. So you need to know the frame structure. What is the structure of the frame? Yeah, they'll ask you this in interview questions. Like if they want to touch your SAN basics, okay, then they'll ask you this question. They'll ask you about fiber channel layers, and they'll ask you about a frame structure as well. So every frame will be divided into 5 parts. Okay, every frame will be divided into 5 parts. The first part of the frame is SOF. SOF means nothing but start of frame. Start of frame. The size of a, so this indicates that this is the beginning of the new frame. Okay, and the size of the SOF will occupy 4 bytes from the entire frame size. Next thing is header. Header. Header will occupy 24 bytes. What header will contain? Header contains the control information of the frame. That means it contains like a metadata, like what kind of data this frame contains, um, like that. In detail information about the frame, actual data will be stored in the header. You can say that it is a kind of indexing. Okay, like in book we will be having indexing pages, right? The same thing, like header contains the metadata of the original data. Next thing is payload. Payload will occupy the major part of the frame, which is 2112 bytes. Okay, 2112 bytes. Just a second, guys. Yeah, sorry. A payload will occupy 2112 bytes in entire frame. Okay, so what payload will do? Payload is the place where our actual data, the original data, will be resides on. Like whatever data we are sending, the actual data will be stored in the payload section only. Okay. Next thing is CRC. CRC means nothing but cyclic redundancy check. Okay, CRC will consume like 4 bytes from the entire frame. So what CRC will do? CRC means cyclic redundancy check is a two-way authentication mechanism. Okay, which is a two-way authentication mechanism which will maintain the source and destination information. So what it will do, it will contains from where this frame is coming and to where it has to go. It contains that kind of information. So what it will do, whenever it is sending from the source, in the source it will check that it will grab the source information, who is sending the information, and also it will also store to whom it has to reach. Okay, that information. Whenever it reaches the destination, it will check with the destination, um, like this frame came from this particular source, and it will check with the destination, do you accept the data from this source? Okay, if destination accepts, then only it will end, the frame will be enter into the destination, inside destination, or else it will fail, like that. So CRC is a two-way authentication mechanisms. Okay, two-way authentication mechanism which will check for authentication on both source as well as destination. So it is the one which will make sure that the data is reaching right place. Okay, so next thing is EOF. EOF means nothing but end of frame. So end of frame also will occupy 4 bytes, and this indicates that this is the end of the frame. That means again a new frame will come. Again it contains same thing: SOF, header, payload, CRC, EOF. Again once EOF is there, next again new frame will come with SOF and all. Okay, that is what it is indicating. Any questions on frame structure? Very important, frame structure. They'll ask you like what all the things will be there in the frame. What is the structure of the frame? They'll ask you. You need to explain them. Okay, we'll don't worry about the troubleshooting part and all. Most of the concepts will be covered during the troubleshooting itself, regarding the layers and all. Okay, we'll discuss about them there, but I don't want to discuss all these things now itself when we are talking about the basics, because most of you are not working on SAN, right? So it will be very difficult for you, and it will confuse you. So you'll be scared of this topic. That's why I don't want to go in depth. Okay. So any questions on frame structure, fiber channel layers? Nothing we discussed. You need to just remember the name. And any questions on other things? Okay. So now let's talk about switches. Okay. So far we discussed about a fiber channel, right? We have, so if fiber channel network is same for all the switches. Like if you are using whatever organization switch, like for example in storage we have EMC, Netapp, Hitachi, IBM, right? The same way, when you are talking about the SAN switches also, there are so many companies which are manufacturing the SAN switches. Okay, it is same, whatever the concepts we have discussed so far, it is same for all the SAN switches. Okay, so let's talk about them. SAN switches. So there are three vendors for manufacturing the SAN switches majorly. Like there are more than that, but major vendors. First one is Cisco. Second one is Brocade. Third one is Megdata. And even recently Juniper, they also started manufacturing the SAN switches. Okay, you can say four now. So Cisco, but among these four vendors, okay, Megdata is not there anymore. Megdata, they merged with Brocade, I guess. I don't remember. Brocade or Cisco acquired this Megdata. So Megdata switches are not separate switches anymore. Uh, I mean, they are merged with the Brocade or Cisco. I don't remember. Yeah. So again, we have only three major vendors. But among these three or four, okay, most of the organizations will use these two vendors only. Just like how most of the people will use EMC and Netapp when it comes to storage, the same way when it comes to SAN switches, most of the organizations will use 90% of the organization, not 90, 99, I can say that. Okay, 99% of the organizations will use either Cisco or Brocade, because they are the market leaders in SAN switches manufacturing. But among these two, again, most of the people will prefer Brocade switches. Okay, most of the people will prefer Brocade switches because Brocade switches uh, easy to manage, easy to manage, and also the amount of features. Okay, and also management tools, the amount of management tools we have on to manage the Brocade switches. All these things will, yeah, will make the Brocade switch management very easy. When you compare them with Cisco switches, Cisco is little complex to configure. Okay, Brocade is very easy to manage. Even that is the way I feel so far. Okay, I worked on both the switches, but so I mean, when I worked, I worked like 5 or 6 companies. Out of that, only one organizations I got a chance to work on Cisco. Remaining all organizations, they are using Brocade only. Okay, so yeah. So we are in this course also, we are talking about only Brocade switches. We are not covering Cisco switches. Okay? Because even I don't have a Cisco switch to show you practically. That's the reason. Another reason. Okay. Okay. So when it comes to brokerage switches, okay, they have divided the SAN switches into two categories, two types. One is department level switches. Second one is director level switches. Okay? Department level switches and director level switches. So here the department level switches are very small switches, okay, which will contain less number of ports and will give you less performance when you compare them with the director level switches. Okay. And when it comes to director level switches, they'll give you more ports, they'll contain more ports, and they'll give you very good performance. And also the way they built is will make sure that there no downtime required whenever you are doing the maintenance activities and all. But when it comes to department level switches, whenever you are doing maintenance activity, you need downtime. Okay, we'll talk about that. So now let's talk about the first director level switches. Director level switch architecture. We'll talk about director level switch architecture. So normally director level switch will be like this. There will be a big cage. You can say this is a big steel frame or iron frame. Okay, we'll call it as a cage. Okay. So this cage will be divided into parts. Okay. Two, three, eight. 1, 2, 3, 4, 5, 6, 7, 8, 9. Um, we'll be having 10 actually. Okay, like this. So out of them, okay, two blades will be okay. We will call these as blades. Blades. Okay. The entire thing is a cage kind of thing, and the inside cage will be having blades. Out of these two blades, we'll call them as blades. We'll call them as SP blades or CP blades. We'll call them as CP, service processor or control processor blades. Okay, so these blades contains management port of the switch. Okay, management port. Along with that, they'll be having ILO port. ILO port means nothing but console port. Just like in Netapp, we have a console port, right? The same way here also we'll be having ILO port. Okay, ILO port of the switch. Not only that, all the other components like motherboard, RAM, ROM, to store the switch configurations, to store the switch operating system, everything will be stored here only in these service processor or control processor blades only. Okay, whatever things related to management will be having everything stored here only in these two blades only. And again, why we have two blades? Even one blade went down, still we have other blade which can take care of everything, right? So that is the reason we'll be having two blades here. Okay. The whatever the remaining blades, okay, we'll call them as port blades. Okay, we'll call them as port blades. The position is not like this. Like if you want, you can install the SP or CP blades on the end as well. But yeah, most of the people they'll install them on middle only. I mean, will get them in middle only. Okay, these are port blades. Means the actual ports, SAN ports, will be hosted on these port blades only. Blades only. So these, yeah. Any questions? Someone unmuted. Looks like. So these port blades contains the ports. I'm not going to draw all the ports. Okay, just I'll draw in one port blade. Okay, the blades looks like this. The ports in the blade look like this. Okay, and again in the port blade, all the ports will be divided into groups. We'll call them as port groups. Okay, this is one port group. This is another port group. Like that, all the ports in a single blade again they'll be divided into groups. We'll call them as port group. Okay, we'll call them as port group. So under every port group there is a processor which we'll call it as ASIC. ASIC. I don't remember the full form of ASIC. Asynchronous something software specific circuit. I don't remember. I'll tell you. But yeah, there is a processor or chip called ASIC, which will be having under every port group. Okay, every port group will contain ASIC. Okay, all the ports in that port group will be taken care by the ASIC. Okay, the port speed, the port type, not only that, the port firmware, everything, whatever things related to the port in that particular specific port group will be managed by ASIC only. Okay, so and also yeah, yeah, we'll talk about that little later. ASIC. Okay, so like that, every port blade it contains a again multiple port groups, and port group in the back end of port group will be having ASIC which will maintain the ports in that particular port group. Okay, this is how the director level switch architecture will be. So we'll connect all our storages server to these ports in the port blades only. Okay. Okay. Generally, the models, the example models for director level switches are 12K, 12,000, 24,000, 48,000. All these are older models actually. Whatever we discussed, these three models. Now we have DCX series, DCX4, DCX8, DCX 8510, DCX 8510, 8510, 8510, like these are the latest higher director level models in Brocade. Okay, let me show you that. I'll show you the diagram as well, how they looks like. Excuse me. Images. Okay, so normally Brocade director level switch looks like this. See, if you see here, not this actually. Show you switch. Uh, So yeah, this is the 48,000 switch, Brocade 48,000 switch. If you look here, see, this is the entire cage, right? And these are the blades inside the cage. And see, these two are the control processor blades. These two. Let me change it to red. Yeah, these two are the control processor blades, and these all are port blades. And again, if you see, and port blades will it is divided into groups, small groups. See, this is one group. This is another group. Yeah, this is how it will be. And one more thing is the advantage with port group, this director level switch is you don't need to buy entire switch. Okay, you don't need to buy entire switch. That means, let me show you that there will be a diagram. See here, yeah. If you see here, see, in this switch I have only here two port blades, here two port blades. Remaining it is showing empty. That means I can purchase the blades whenever I need. I don't need to purchase a full switch. As per my requirement, four port blades are enough for me to fulfill my requirement. So for now I installed only four port blades. CP blades are you must have two. Okay, later, for example, if my all four port blades ports are full, then what I can do, I can purchase a blade and license, and I can install that blade here. Instead of what I can do, I can remove this cover and I can install the newly purchased port blade here. Like that, based on your requirement, you can purchase the blades whenever you need it. Okay, you don't need to purchase entire switch itself directly. Okay, that is another advantage. If you see here, see the same thing here. We have only purchased four port blades, remaining are empty. Okay, like that. Okay, one more thing. Normally comes to 12K, 12,000, 24K, or 48K. Okay. For example, if you want to connect one switch with another switch, what you need to do? You need to use the normal SAN ports only, even to establish the connection between these two switches. Okay. We'll use either two or four switches, four ports. So that with the help of these ports only, we have a concept. Actually, we'll discuss more about that little later, maybe tomorrow or day after tomorrow's class. Okay, but normally yeah, we will use the same ports for host connectivity. We'll use the same ports for connecting one switch to another switch as well. But only thing is you need to do a little configuration changes. Okay, or even switch also can configure on its own based on the connected device. Okay, so this is how you need to. But we'll call it as, we'll call this as ISL, inter switch link. We discussed about it when we are talking about a cluster switches, right? ISL. The concept is same. If it is a SAN, if it is a NAS, when you are connecting two switches, we'll call that connection as ISL, inter switch link. Okay, it will establish the communication between those two switches. But here we are wasting four ports, right? Instead of connecting these two switches by using four ports on switch one, four ports on switch two, we can use the four ports for server connectivity or storage connectivity, right? That is the reason what they have done in DCX series. They have added two separate blades for inter switch connectivity. We'll call it as ICL. Okay, inter chassis connectivity. Inter chassis connectivity. Here, okay, along with the CP blades and port blades, we'll be having chassis blades, two chassis blades. Okay, here we'll be having separate ports, which are different to normal SAN ports. Okay, what we'll do, instead of using the normal SAN ports, we can use the ports in these blades to connect to each switch. I mean, we'll connect one port from here to here. so that with the help of ICL connection, now my two switches will be able to communicate with each other. Instead of a normal traditional ISL, we can use the ICL connections. Yeah, I'll show you in DCX switches, you'll be able to see them. Okay, normally if you see here, yeah, see, this is what I'm talking about. This is the ICL port, ICL blade. This is another ICL blade. So we'll connect this port to another switch port, ICL port. Okay, like that. DCX series only will have this kind of thing. Normal for 12K, 24K, 48K, we'll use normal SAN ports only. We don't have any ICL. Okay. If you see here, this is a 48K switch. See, I don't have any ICL chassis, ICL blade. But in DCX, yeah, you have a separate blade called ICL blade. Okay. Any questions on director level switch? Okay. And when it comes to department level switch, okay, okay, when it comes to department level switch, there is nothing you can do. Okay, these are pretty straightforward actually. No chassis, nothing. It is a normal single switch which contains everything in a single slot, like management port, ILO port, normal SAN ports, everything will be there. It will be like this. It is having very less number of ports. Yeah. So, and one more thing, there is no way that you can purchase only these blades and you can purchase later, nothing like that. You need to purchase entire switch here. Okay. Even if you don't have a requirement also, you must purchase a entire switch. So when it comes to models, we have a lot of models in department level. Um, like 3520, Brocade 300, like that. Lot of models are there. Yeah, see, not G series. Series is for NAS. Yeah, Brocade 300, 60 to 50, like that. A lot of models are there. You'll get them normally when you do. See, like yeah, 300, 6505, 6510, 6520, like that. Lot of models are there. Okay, we'll get them list. You can pick a few models from here and you can use them in interview. You can tell them, okay, we are using these switches in our environment, like that. You can tell them. Okay. See, these are the director level switches. Any questions? Okay.
Naveen.
So shall we continue or?
Like, what's the next topic now? Like, is there any big one?
Yeah, we'll talk about FCP only, but I just want to show you. Yeah. Okay, let's do it
Yeah,
tomorrow because I
we
just
can,
want to talk
we
about.
can, yeah, yeah.
Sorry.
Uh,
Didn't get.
yeah, yeah, I'll continue. Like, today is anyway, we don't have much work, right?
Mm-hmm. Okay.
We do, like,
So
what about remaining? Like, I don't want to have, like, on my side, like, we lost the remaining number as well. Jubair or Akila, like, anyone.
yeah, yeah.
Anyone, like, you want to continue today or, like, we will stop today? Like, anyone?
Okay. Let's finish the port types. Yeah. So port types. Let's talk about the port types. So normally we have different port types in SAN. Okay, this is not only dedicated to brocade switches or Cisco switches. This is common for all the switches, like the port types. Okay, so let's talk about the port types. So generally we have port, F port, N port, FL port, NL port. Like that, we have so many port types. Not only these, but these are the most important and generally used port. Okay. Apart from this, we do have other port types as well. But yeah, I'll not discuss about them because uh, those port types we normally L4 guys deal with them for FCIP routing and all. Okay. So yeah, let's skip about that. So G port. G port means nothing but it is a generic port. Okay, it is a generic port. So normally, by default, all the switch ports in our switch will be by default a G port only, unless if you have configured it specifically to any other port. Okay, it stays G port only. So a G port can be converted into, and one more thing I forgot actually, E port. Okay, so a G port can be converted into either F port or FL port or E port. You can convert a G port into any of these ports. Okay, any of these ports. So how it can be converted? You can convert it by using a command. You can convert it, or it will be automatically converted if you connect a device. For example, if you connect another switch, then it will be converted into E port to one switch to another switch. If you connect a storage or server to that particular G port, then it will be converted into either F port or FL port. Like that, based on the device connected, it will automatically convert also. Or else you can convert it manually by using by running a command as well. Okay. Next thing is F port. F port is nothing but it is a fabric port. It is a fabric port. So to this particular F port only, we connect our servers storages. You can convert this port by using a command, or automatically it will convert when you connect a server or storage to that particular port. Okay, as a F port, from G port to F port. Next, N port. Actually, N port it will not resides on the uh, switch. Okay, it is host initiator port. It is a initiator port. Initiator means nothing but our server HBA or storage FCA. That we'll call it as N port. That means we'll connect our N port to F port. Actually, N port does not belongs to switch. N port will not resides on the switch. Okay, N port resides on server or storage. Server HP or storage FCA will be there, right? That port which we are connecting to our switch F port, we'll call that port as N port. N port means nothing but node port. We'll call our switch or storage, sorry, not switch, our server or storage port as N port. Okay. Next, FL port. FL port means nothing but fabric loop port. Okay, fabric loop port. So in FL port also normal, just like F port only, but instead of connecting direct server or storage, we'll connect a fiber channel arbitrated loop to switched fabric. For example, I have configured a switched fabric here with 2 switches. Okay. And I have a server which is already part of a FCAL loop. Let's assume that. Normally, you don't see these kind of scenarios now, but in earlier, like 5 years back or 10 years back, yeah, there are like I have this server which is already part of FCAL, but I just want to connect this particular server to my switched fabric as well. So I want my server to be part of both the fabrics. So in that situation, what I need to do, I need to connect my FCAL topology with switched. I'm mixing two topologies together. In that kind of scenario, you need to configure the port on switch end as FL port. Okay, FL port like that. And the same way, NL port means nothing but whatever the device you are connecting from FCAL, like if it is a server or storage, whatever it is that you are connecting, okay, that okay, FL port means connect AL. Okay, NL port means and it is a initiator from FCAL. That means it is a either server or storage. Okay, yeah. N port, just remember, don't get confused. N port is not a port on a switch. Okay, it is a either server port or storage port. That's it. Okay, we'll connect our N port to F port, NL port to FL port. That's it. Okay, next E port. E port means nothing but expansion port. E port means expansion port. Okay, so expansion port, nothing but one switch to another switch. Okay, for example, in a fabric, I told you, right, in order to create a fabric, I am connecting here two switches together, right? So the port which I am using here, that is a E port, and the port on the other end, other switch end also, it is a E port. So we'll connect two switches together with the help of E port only. Okay, by using E port only, we can expand the our fabric by adding more switches. Okay, with the help of E port only, the switches will be able to share configurations with each other. Okay, these are the most used port types generally. Apart from this, we do have more port types, but yeah, what I'm going to do, I'm going to give you a document where it contains in-depth information about the port types, other port types as well. But those ports, if you want to understand them, you require you need you know L4 level knowledge to understand them, because that those ports are related to FCIP, those kind of things. Okay, fiber channel with IP routing and all. Okay, yeah. So any questions on port types as well? Mostly, yeah. See here in this diagram, they explained you quickly. See, this is my server, which is N port means my server HPA. I'm connecting it to F port on the switch, fabric port, like that. See, and I have one switch here, and this is another switch. I'm connecting these two switches with the help of E port. Like the same way, I have NL port, which is the server is part of FCAL loop, and I'm connecting it to FL port, like that. There is a diagram also which will help you. On here, you have the abbreviations: what is NL, what is FL, what is G, what is E, like that. Okay, just go through this document. I think I have already uploaded this document as well, but don't go through everything. Just go through the document, go through the topics only we covered. This contains like more information than that, which might confuse you. Okay, yeah, let's stop it for today, because I don't, because if I start floggy the process again, it will be like one full day topic. I need to discuss zoning and all also. Yeah, we'll connect tomorrow because it will take like one full day class, like 1.5 hours. So let's talk about that tomorrow. Yeah, maybe. Yeah, we have two more classes. Within two more classes, we'll be able to finish entire FCP. Yeah. After that, we'll start it. And guys, one more thing, as we already started SAN,